This video will review dilations of functions. Now, dilations are part of the transformations of functions, but this will be what's happening to the function from the parent function. So we're looking at the a in our format of f of x equaling a times the absolute value of x minus h plus k, or f of x equaling a times parentheses x minus h squared plus k. Now the location of the a is very important. So when the a is on the outside, such as this first example, if the a is on the outside, this is a vertical stretch. And it's going to be a vertical stretch when a is on the outside. It's vertical because a is on the outside. It's a stretch because the absolute value of a, whatever value of a is, it's bigger than 1. Now if a is on the outside, it's still vertical. But if it's between 0 and 1, so if it's a fraction between 0 and 1 or a decimal between 0 and 1, it's compressed vertically. Now, if the a is on the inside, that means you have horizontal movements, such as these bottom two. Now, you're going to have the horizontal movement. It could be a compressed horizontally, or it could be stretched horizontally. When the a is on the inside of the brackets, like the absolute value or the parentheses for a quadratic, if it's greater than 1, it's compressed horizontally. Now, the graph of a vertical stretch, so a graph of a vertical stretch and a horizontal compression, they look identical. These are both going to have a's that are greater than 1. The only difference is where the a is located when you write the equation. Now, if the a is on the inside, or if a is less than 1 but greater than 0, that would be a vertical compression, or it could be a horizontal stretch. Again, that's when a is less than 1 but greater than 0. So again, where the a is located determines if it's vertical or horizontal. But if it's less than, the absolute value is less than 1, it's either going to be a vertical compression or a horizontal stretch. So we'll take a look at some examples here, being able to write the function based on the description that they give us. So the first example says write g of x, the transformation of f of x equaling x squared, and we're going to translate it down 5 units. It's going to go to the right 3, and this is a stretched vertically by a factor of 2. So again, I'm going to put the main format for a quadratic. So this would be f of x equals a times parentheses x minus h squared plus k. Now for this one, they're telling us label it g of x. So I'm going to put g of x here equals. Now it says it's a vertical dilation. That means the a is on the outside, and the a is the factor of 2. So I'm going to put 2 on the outside, and I'm going to have x. Now it says that it's 3 units to the right. So normally it's x minus, so I'm going to keep that in there. My h is 3. So I can put that in parentheses. So I have 2 times parentheses x minus 3 squared. And then it said it went down 5 units. That means my vertical translation is minus 5. So here would be my function of g of x equaling 2 times (x minus 3 squared minus 5. Next one, write g of x, the transformation of f of x equaling x squared. This one, we're going to translate it up 5 units, to the left 3 units, and this one's a compressed horizontally. So this is a horizontal movement so that the a is on the inside, and our a is going to be 2. So I'm going to have g of x equals, since the a is on the inside, I'm going to put 2 on the inside, and this would be 2x, and then 3 units to the left. Normally it's x minus, but because my h is a -3, I'm going to make it a +3. This is squared. And then it's translated up, so that's a +5. So that would be our function. Next, here, these are going to be the opposite of what we just did in the previous slide. So here we're going to write g of x equaling the transformation of f of x equaling x squared, translated down 5 units, right 3 units, but this one is compressed vertically. This is a vertical movement, so the a is on the outside, and our a is a 2/3. So I have g of x equaling, on the outside it's compressed because my a is less than 1, so I have 2/3, parentheses, x minus, it's 3 to the left, or 3 to the right, so my h is 3, so b squared, and then it went down 5 units. In our last example, g of x, write g of x, the transformation of f of x equaling x squared, translated up 5 units, to the left 3 units, and this one's stretched horizontally by a factor of 2/3. So this is a horizontal movement. It's a stretch horizontally because my a is less than 1. So again, my function would be f of x equaling, it's horizontal, so it means it's on the inside. So I'm going to have 2/3 x, and then it's a stretch. So we already did the stretch part. It's going to the left 3, so that means it's at -3. So x minus a -3, which means x plus 3 squared, up 5 means +5. So that is a quick review of writing equations when you're focusing on the dilations of functions.